In an earlier video I introduced the Raspberry Pi Zero W, which is the compact Raspberry Pi Zero that's now got Wi-Fi built in on board, and so this is a £10 board, so it's quite cheap, and because it's got the connectivity built in, it's really ideal for Internet of Things projects. So today I've got the Raspberry Pi Zero W installed with Diet Pi software. So I chose Diet Pi because I've got quite a small SD card installed here and I wanted to keep it as light as possible. And I've added a sensor here. So this is the Dallas 18B20, which is a temperature sensor. So what I'm going to do is I'm going to take readings from this temperature sensor and I'm going to send them up to the internet. Actually, I'm going to send them up to Amazon Web Services IoT service, so AWS IoT, and so you'll be able to see the temperature messages coming from here and ending up on the Amazon site. Now, so if we look at the Dallas 18B20, let's try and make that focus a bit better. So you see the Dallas 18B20 is a tiny thing. It looks a bit like a transistor, so it's only got 3 legs, but in fact it's much more sophisticated than a transistor. It uses a protocol called one wire, and with one wire you can connect several devices all to the same wire. So you can actually daisy chain multiple temperature sensors all to the same wires and have multiple readings coming from different places, and it's really easy to do with the Raspberry Pi because the drivers are built into the operating system to allow you to easily read it. So let's start setting it up. So the first step is to show that I can read a temperature value from the sensor. So there's some code that I've written here in Python. I'll explain in more detail how this works shortly, but let me just get it up on the Raspberry Pi and we can get started. So I've got the Raspberry Pi connected to the Wi-Fi here. Just copy over that file, and now we'll connect into the Raspberry Pi. Okay, so this is the Raspberry Pi. So as I said, it's running Diet Pi software. So I'm trying to keep the amount of memory to an absolute minimum on this because it's got a very small SD card. But it's a good exercise in any case. In the past I've used Raspbian a lot as the operating system on the Raspberry Pi, and so this is the first time that I've used Diet Pi. It's very similar in style, but it's just much more lightweight. Doesn't need so much in the way of resources. So let's first get that file the file that I just uploaded into that current directory. So there we go. So I'm going to check whether the sensor is loaded first of all. So if I have a look at the config.txt in here, and you see at the bottom here, this line here, dt overlay equals w1 GPIO, this is what I'm looking for. So this W1 GPIO means that the one wire driver is loaded. So the one wire is what I need in order to be able to interact with the Dallas 18B20 temperature chip. So that means if I now go into sysbus W1 devices and list out the files there, you'll see on the left here this numeric directory name here. This represents that particular Dallas 18B20 chip. So each one of these chips, it's quite nice, each one has an individual 64-bit ID burnt into it in the factory, which means that if you connect them all on the same wire, so if you connect 5 or more of them on the same wires, then you can see 5 different identifiers and you can address them individually. So if I go into that directory now, there's a file called W1 slave over here. So this is actually it's a pseudo file. It's not really a file. It represents the device. So if I do cat to print out the contents of that pseudo file, you see there's a short delay there, and that's actually because the operating system is talking to the Dallas 18B20 and it's getting a temperature reading, and then it formats it as though it were a file. So you can see there's 2 lines in this file, and the thing that I'm going to be looking for is that this line 1 says yes, which means that the operating system has successfully got a reading from the DS18B20. And then on the second line here, you'll see at the end there's this T equals 24187, and that's actually the temperature reading. So it's saying that the temperature is 24.187 degrees centigrade. So it's taken a centigrade reading and passed it back in that way. So let me just grab this unique ID number, because I'm going to need that in a second. If I go back to my home directory, and I'll load up the Python file that I'd already written. So here I'm going to put in the ID of that particular sensor. And now we'll run a test. So we'll run Python read temp. There we go. So that's read the temperature sensor, and it's returned 24 degrees C. And so we've proved that the sensor is working. I'll just show you in more detail what that code actually does. So you see here I've got a function called read temp, and this is the main part of the code. So in the main part of the code, what I'm doing is I'm setting that sensor name. I'm making a reading from that temperature sensor, and then I'm printing it out. So it's just a pretty normal temperature, a pretty normal sort of print string. I've put U here for Unicode because what I wanted to do is put in this little Unicode symbol, which was the degree C symbol you could see on the screen. So you see up here it actually says degree C at the end, so I was using Unicode for that. So how does this function work? Well, what I'm doing here is I'm going to this directory that we just saw, the sysbus W1 devices. The %s represents this unique 64-bit ID for the sensor, and I'm opening that file. And now, having read lines out of the file, what I'm doing is I'm checking line 0, so the first line, to make sure it's got a yes in it, because you remember that when we looked at the file, the in fact if I scroll down, So the first line of the file says yes if you've got a successful temperature reading. Then if that's okay, I then do this pattern matching request here. So I'm looking for something that says t equals and a number of digits, and the brackets there mean that I'm grabbing all of the digits out of that string. So again, if you look at line 2 of the file, you can see we've got a t equals 24187. So I'm grabbing the 24187 out of there and then divide by 1000 because it's 24.187, and then I return that as the temperature value. So this is just quite a simple Python formatting type function. So it extracts the value out of that pseudo file and then presents it in a nice way. And so we're going to use this function later with Amazon AWS IoT. Okay, so there's one more thing before we go on to the AWS site. I know that the next step requires us to have Git installed, so I'll just start installing Git. Because I noticed that DietPy doesn't install Git by default. So we'll just start that going, and we'll go on to the AWS console. So here we are on the AWS console. I'm going to select AWS IoT, which is the service that I'm interested in today. And if I go into Connect, so I'm going to set up a new device. I'm going to use this configuring a device wizard here because it packages up all of the steps that you have to do, and it's really very easy. So let's do that. So today I'm going to be using Linux because DietPy is a type of Linux, and I'm using Python. So I'll give the thing a name, so let's call that DietPy. So we've got successfully created thing, and now download the connection kit. So this is important. So this is all of the certificates that have just been created, all bundled up together. So each device in AWS IoT has its own unique certificate, so that all of the deployed machines you have in the field will have a unique identity, and they can all be authenticated as real devices that you've created. And this also includes a file which will reach out to the internet and download all of the files that it needs in order to actually send data into AWS IoT. So we'll do the download. So we've got the connect device package.zip, which we'll use on the Raspberry Pi in a moment. Yeah, so this page just summarizes what the steps that you need to take when you've copied the files over onto the Raspberry Pi. So we'll say done. So that's basically all we need. So now we have this new device here, DietPy, and there's not much that we can do with it at the moment until we've installed the software on the Raspberry Pi. So here it mentions MQTT. So MQTT is actually the system that AWS IoT uses for the devices to send messages into the cloud. So MQTT is a message queue system, a lightweight message queue system that allows two-way communication between the cloud and the device. Okay, so we're back on the Raspberry Pi side now. So I've just got this zip file that AWS IoT have created for me, and I'll copy that onto the Raspberry Pi. Okay, so let's copy that out of the mount directory. Okay, so if I unzip this file from AWS IoT now, you'll see it's got several things in it. So this private key, public key, and certificate. These are the security certificate files that Amazon have created for me that uniquely represents this particular Raspberry Pi. And now we have also this file start.sh. So this is a script which, when I run it, will download the necessary software that I need so that I can communicate with the cloud using MQTT. So I need to make that writable first. Now if I run that, this might take a little while, so I might speed through this bit later. In fact, that's not too bad. So now it's downloaded the file. It's actually running the SDK test file. So if you look here, these are actually messages now that the Raspberry Pi is sending via MQTT up to the Amazon cloud. So it keeps incrementing this number here and sending a message every second up to the Amazon cloud. So if we now switch back to the AWS console, we'll be able to see these messages coming in from the Raspberry Pi. So let's do that. So we're back on the AWS console again. Let's go to test. So this is where we can send and receive MQTT messages, so we can interact with our Raspberry Pi. So subscription topic, I'm going to put hash, which means I'm interested in all types of messages that I can see, and say subscribe. And now this little red dot here tells me that it's seeing some traffic, so I'll click on that, and here you can see the test messages coming from the Raspberry Pi. So at the top here is the most recent one. You can see that this string here, the SDK test Python, is actually the subscription topic. So the Raspberry Pi, the application on the Raspberry Pi is using that as the topic that it marks every message with. And here's the actual content of the message. So you can see we're up to 490, so 495 now. So the Raspberry Pi is still sending messages 1 per second into the console. And down here you can also use this field to send a message back the other way that will be received by the Raspberry Pi if you want to do that. So the next step is to bring those two things together. So we've got the AWS IoT SDK test program that's sending these test messages into the cloud, and we have the temperature sensor which can be read by Python. Now I'm going to glue those two bits together and do some cut and paste with the Python and make it so that the temperature messages actually reach the cloud. So back on the Raspberry Pi, now what I want to do is get some of that code that I was testing with earlier from read temp and put that into the Amazon SDK file. So first of all, if I edit the test file from Amazon, so this is the code provided by AWS IoT. I'm just going to put my import re in there because my code needs that function, and I'll bring in the code from my read temp. So let's just cut that function out. Reading the sensor. And I also want these lines here where I read from the particular sensor that I've got. Okay. So down at the bottom here, this is where they are generating their test message. So I'll go in here in the main while loop. Need to get the indentation right because Python's very fussy about that. In fact, that doesn't need to be in the loop. Let's put that there. Okay, so message equals, and let's construct some JSON. So I'll say message object temperature T, and I'll say JSON dumps message object. Oh, don't need that. I'll change the key here so the subject, so it looks different in the console, and we'll remove this default message. And we'll put in our message in there instead. It should be okay. Let's just do import JSON as well. I'll need that. Okay, and now we'll run it, see if I've made any mistakes. Ah, yes. Unindent does not match any outer indentation level. Okay, I had to change these indentations because Python's very fussy with tabs and spaces, but that should be correct now. Let's run it. Okay, so we're sending messages. Subscribe, and there we go. So now we're seeing SDK test temperature, which was the subscription topic that I selected in the application, and now you can see the JSON in here. So we've got temperature and we've got the reading in Celsius, and so that's it. Now we've got JSON data going onto the platform. Later on we could pick up this, so using the rules section in AWS IoT, we can match the JSON data that we've got here, and we can send these values into Amazon S3, or we can send it to Amazon Kinesis for storage or further processing. Let me know in the comments if you want me to do that, if you want me to connect it to Kinesis Firehose, or if you want me to store the data coming from sensors into Amazon S3. So if you've enjoyed this video, give me a like. As always, thanks for watching and listening, and see you next time. Just one more thing that I thought might be a bit of fun is I've added a second sensor. So I've plugged in the a second Dallas 18B20. So I just literally put all the pins in parallel with the ones that with the one that was already installed there. And now if I look once again at my bus directory, sysbus w1 devices, see now I've got two different sensors visible, so two different pseudo files named with the unique 64-bit ID of those devices. So now what I've done here is down at the bottom of my program I now have a list of two sensor names, and what I'm doing here is on odd and even loops, iterations around the loop, I'm changing the name between one file name and the other. And also in the subject key here I'm sending temperature, and then I'm inserting this key name in here. So if we run this now, we should get different output on the console. So let's start the application up and go back to our console. Once again, subscribe to Hash. We've got a little red dot, so we'll click on that, and now you see we're getting different readings, so it's alternating between 26 and 25 point something, and you can see now we've got the two different sensor names. So we've got the one that ends in F8 and the one that ends in 03. So now we're reading two different sensors and sending them in with two different MQTT subscription topics. So you see this is a quite flexible way of reading multiple sensors, and you can read multiple sensors from one Raspberry Pi, or you can have one sensor per Pi. And as far as AWS IoT is concerned, both are equivalent. Okay, so once again, thanks for watching, and see you next time.